So hi everyone, thank you for joining us today. Some more people are joining. I'm Varmaraja, I'll be moderating the session. You'll see I'll show you like 1 minute and times up slide. And please welcome Madhav as our first speaker.
Thank you. Thanks, Rob. So we're happy to be here. Thank you for including us in the program. This is joint work with some lovely people at Pedro. And it's about designing and deploying an inclusive recommendation system at one of the largest visual online platforms in the world. And I'll walk us through. Let me start with something that's touches close to heart. This is, in marketing parlance, this is called listening to the voice of the customer. Normally people just call it listening, but this is a powerful reminder of the impact online platforms can have on personal identities and people's sense of self-worth. So this is a user saying that, hey, if I come to a platform, I find it very difficult to imagine myself on it, because when I'm looking for things related to maybe beauty or fashion, I kind of have to type my particular skin tone to get the right kind of results, but it seems that's not generally the case with only applicants. And you may say, okay, Madhav, this is like a particularly evocative quote for the first slide of the presentation. But I think I would argue that the problem is more pervasive. Platforms all over the world have been accused of being discriminatory and exclusionary on the creator side, on the user side, as well as on the recommendation side. And I think a particular reason why the platforms tend to be so biased is because of recommendation systems, which are these key vehicles that deliver personalized content to users. They tend to amplify bias, create filter bubbles that eventually lead to pigeonholing consumers' experiences, just giving them a very narrow sliver of content that may exist on the platform. Subsequent models then train on this data, kind of making those bubbles more and more narrow over time. And today, so much of societal discourse and our online consumption, digital diets are mediated by this platform, right? About 80% of the hours streamed on Netflix are directly attributed to the existence of recommendation systems. So given that we know users are dissatisfied, we know that the problem is ubiquitous and pervasive, and we also have a potential cause behind the problem, then the big question is, can we do better and build better recommendation systems? So that's what this paper is about. So we have a 3-step solution. So this paper has a very sort of engineering kind of a flavor. We find a problem and then we build a solution to solve it. We solve it and then we see what happens. The first part of this is actually building that solution, which is what we call an inclusive by design strategy, which is coming up with a recommendation system that is representative of the users that the platform intends to serve. That's a mouthful. I'll walk us through it more sort of swiftly in this case because of the lack of time. So I'll not emphasize so much the method and the exact solution, but focus more on the results, but I'll still give you a flavor of how we'll solve this problem. And the key phrase that you want to be Googling after this is determinantal point processes, which is essentially a review of linear algebra from high school. Okay, once we have this solution in place, which is this new inclusive recommendation system deployed on Pinterest, we then causally examine how that impacts key engagement metrics on the platform, and how does it change the distribution of content that consumers are served and what they engage with. And then finally, we pin down the mechanism as to why do we see what we see. Are there particularly heterogeneous effects? Are some users benefiting more than the other? What are the long-term implications? And how do you take what we built here to other platforms? So that's the scope of the work. Fortunately, we're in a small room, so please feel free to pause me at any time for any questions. But for now, I'll move forward. Okay, first part. How do you design an inclusive recommendation system at Pinterest? But for that, we need to know what Pinterest is. So it's a very visual platform in case you haven't seen it. Let's think of it the flavor of, for example, Instagram or TikTok, but instead of a social network, it's an interest-based graph. So which means, let's just say you're looking for new wedding clothes. You want to go to Pinterest, you find ideas, and then you kind of develop your own portfolio, what kind of clothes you'd like to buy. It's actually one of the largest platforms in the world. There are about 500 million monthly active users and about 12 billion items of content on the platform. And there are multiple surfaces, much like Instagram, right? If you go in, there's an explore tab, there's a personalized home feed. Same thing here. There's a very personalized home feed that caters to your interest. This is kind of my home feed, my personal home feed. And then there is a search surface on which you can figure out, hey, I would like to search this thing versus that thing, and I will give you results. And this may or may not be personalized. So in this case, I'm particularly looking for white women's shirts. I'm sorry, I should say women's white shirts. That comes out wrong. Women's white shirts. And then you get content that again tends to be less focused on sort of your personal interest, but more on the product or the item that you're searching. And every item in Pinterest lingo is called a pin. If you click on it, it leads you to another surface. Again, much like, for example, you click on a product on Amazon, it takes you to the product detail page. And then you get served a bunch of recommendations that are related to the product or the item that you clicked on. The recommendations that you see below, that's what we are trying to change and improve and make them more inclusive in terms of skin tones of content represented. And I'll make that more precise as we go along. Okay. Yes, ma'am.
What do you know about the person?
So that's a fantastic question. We do not observe the user's skin tone, not to be sort of intent to. I think that's, it may be, that's legally not something that the platform or we support. So this is all based on your interest and what you do on the platform, nothing based on sort of your race, your, except that as much as your gender, for example, you search for women's clothing, that gets reflected in your preference. Okay, that's the intervention service. How do we do this change? Well, first, just in case you may or may not know this, but some bit of background is helpful. Most online platforms have these two-stage deep neural networks that power recommendations. Okay, that's just like a high-level overview. The first stage is if you click on a particular item, it fetches content that winnows it down from 12, 13 billion items to about 1,000 potential items of interest. And then some fancy machine learning rankers will rank out of them and present to you in a sort of descending order of dictated engagement. So this is how generally these models work. It works here as well. What we do is at the second stage, institute something called the determinantal point process. And I'll very briefly explain what it is. There's a lot more detail in the paper, and so one of the emphasis that we do. But just in the interest of time, we'll kind of gloss over it. But what do DPPs do? They essentially define a probability distribution over the power set of all potential items that need to be ranked. So if you have n items that you're going to recommend, there's a probability distribution over 2 raised to the power n potential subsets. That's what determinant point processes do. But what's nice about determinants is that determinants, by the nature of it, how you calculate them, they promote more separate set of points in a latent space. That's just the way determinants work. Okay. I'll leave it at that. Yes, please.
Okay. So you said that you start with 1 billion items and then you narrow it down to 1,000. So that you're going to be using what they were already using. You are just doing the diverse over the 1,000 items.
Yes, yes. I mean, if the question is why not just kind of diversify everything, well, we could. But it's latency. I think it's very difficult to kind of diversify 1 billion items. It's more easy to do it for 1,000 items, and that's kind of the reason. Okay, so what does DPP have? It needs 2 critical ingredients. First is a kernel matrix, which needs predicted item engagement and pairwise item similarity. Okay. And this can be learned with the DPP itself, but it can just be your existing subsystems. You have a stack of neural networks that predicts what the engagement is going to be. You have another neural network that creates embeddings of items. You can just take them and develop DPP on top of it. Okay. So that's defining the kernel matrix. And then you need an algorithm to generate subsets. So you need 2 things for this whole mechanism to work. I make it sound trivial, but it's a lot of engineering work. Our DPP formulation does something cool, that it takes skin tone of the content that you see in images. All content on Pinterest is images. Any piece of content that has a human body part has a skin tone signal. We take that signal and divide it into 4 skin tone ranges going from lightest to darkest. DPP takes the skin tone of the images and then creates a pairwise similarity matrix and then transforms it into a multi-objective optimization problem that balances engagement and diversity. That's essentially the objective formulation that we have. And theta is this tunable parameter that allows us to control how much we want to emphasize engagement versus diversity in case there's a trade-off between the 2. And the goal for using DPP is to strive for a more even exposure of different skin tones in the recommendations that are served per query. And this formulation, what's nice about this is it allows us to kind of create these Pareto frontiers or these trade-off curves that with how we vary theta, it allows us to know how much will we lose in engagement versus gaining in diversity. It kind of gives you this principled way of navigating the trade-off. And this is done on offline replay data, which is randomized, so it removes algorithmic confounding to be able to come up with these curves. And Ron already asked this question, but just in case it's to make it super clear, we do not use any user information, their skin tone, to infer what kind of content they like. It's all based on their activity on the platform. So what does this look like in terms of how the diversification actually happens? So let's just focus on one in the interest of time, the leftmost bar. This is conditioning on that white shirt example that we saw above. Looking at the skin tones of the models represented below, most models tend to be in the lighter skin tone side. What we're trying to do is make sure that this is representative across all skin tones. So this is the original set of recommendations. This is the change after you do DPP. It's an abstract graph, maybe this figure will help. So this is the same example. The one on top is the status quo of how you get the recommendations. Again, the paper has a lot more detail as to why you get to this place, but the key word that you'll be looking for is filter bubbles. Right? So that's why that happens. And then you have to intentionally diversify, and it looks kind of more representative of the beautiful palette that colors humanity itself, which I think is a particularly nice feature of this project. Okay.
So
yeah, please.
You're trading off engagement and diversity, or it's actually improves engagement?
So in the offline test, it can't improve because it's capped, so it's a trade-off. But in online test, it could potentially improve. It could, but it doesn't as a preview. It doesn't, but it could potentially. Okay. With that said, I think the main question that we want to answer is how do these visually inclusive recommendations influence overall engagement, which for Pinterest is measured using the number of items saved. If you're a Pinterest Pro user, the language is repinned. And how does this change the distribution of content that is served and consumed on the platform? Okay. To do this, we run a large-scale field experiment on Pinterest with about 650,000 users. And this is the first stage of the experiment. So let me walk us through this graph. This is saying that if you ask for recommendation, you don't ask for it, but you just click on an item, you get served recommendations. Then among the top 20 items served, how many unique skin tones are represented in those items per query? So, and the black one is control, the blue one is treatment, and essentially you want to focus on the rightmost part, which is saying that there's a threefold increase in the number of queries that show all 4 skin tones. When I highlight this, also realize this is a particularly bad highlighter, which takes away some emphasis. Okay, so that's what we do on the left. Okay, that's the intention of DPP is the first stage. It means that it's working and how it's supposed to work. Something that happens as a byproduct is on the right, because initially some content may be underrepresented. In an effort to make that even, you push up certain skin tone content, you push down certain skin tone content. Right? So the one on the left is intended, that means that DPP is working. The one on the right happens just because of the way the initial system was. And we're going to use this radiation to pin down the causal effect as well as the mechanism. So overall results, which is I think fantastic, overall engagement remains stable. I think this is, I know from a publication point of view, this sounds, oh man, now the results, what's going to happen? But from a platform's perspective, this is actually a big win. Being able to diversify content without hurting engagement means substantial benefits to the number of users that you can serve. And then when we look at consumption diversity, it goes up significantly. There's about 15% increase in engagement with deeper skin tone content, which is basically content with darker skin tones combined with 2 categories. There's 15% increase in the sham entropy of content consumed, which is even length of consumption across all potential skin tones. So that goes up by 15%. And the proportion of users engaging with all 4 skin tone content goes up by 70%. That's on a Logit scale, so exponent -1. So overall engagement is stable, consumption diversity goes up. I think that's a pretty good achievement of the way of how we've been able to solve this problem. But the key question is, why does this happen? And to pin down, we look at both the demand side as well as the supply side. Again, for lack of time, I'll only focus on the demand side here. Recall the quote from earlier. There are users saying that they don't feel particularly welcome and that their needs may not be served by the platform. If that was the case, then with the new system, we may have recommendations that can serve a wider variety of users, right? So what we do is we use historical data from the platform to see what type of content do users engage with, and then discretize that in terms of how diverse their consumption is and look at their heterogeneous treatment effects. That was just a fancy kind of long sentence to say you do heterogeneous treatment effect analysis. Okay, and we use 3 months of pre-treatment data to pin this down. Let me show the results. Let's focus on the leftmost part here, which is the first one, which is overall engagement. This is saying that for users who had a preference for deeper skin tone content, basically who were engaging with underrepresented content before, they actually see a substantial increase in overall engagement by the tune of 11%, which is huge. And the rest of the user base has a slightly negative sort of decrease in overall engagement, but it's not statistically different from 0. So that's what's happening on the demand side. There's the complementary view from the supply side, which is in the paper, but pardon me, I'll have to skip over that just in the interest of time. 2 things which I think are important to mention. Okay, this happens in an experiment. The experiment runs for 4 weeks. Does it really improve the user's experience on the platform? I think that's the key question to answer for changes like this. So we look at data 9 months after launch, and we find that overall engagement continues to remain stable, and engagement with previously underrepresented content continues to be at elevated, that sustains elevated levels, right? And this is true for all other measures of consumption diversity. So that's on the long-term persistence. There's another part of it. Okay, now it sounds like a presumably cool exercise, but does it really have any sort of generalizability or external validity? And there's like a 2-part answer to that. One is the generalizability of the approach. There we are sort of more confident we can make, I would say, persuasive arguments using anecdotes, partly because our approach is kind of built in this modular fashion that you can just plug in your existing recommendation system. Again, details are in the paper. External validity is always hard for these kind of experiments. So the way we show it is we actually diversify content again based on another previously underrepresented category, which is body type. Right? So here we do it, we classify images into sections going from the lower range of body type to the upper range of body type, very similar to what we do before, and we run a similar experiment, do a similar DPP, similar experiment, and see how does overall engagements change. Overall engagement again continues to be stable and consumption diversity increases. In both these cases, why is overall engagement remaining stable? It's all because of the principal formulation of DPP that exactly allows us to pin down how much appetite there is for engagement versus diversity. I will conclude, we developed this sort of scalable approach to diversify content recommendation, one of the largest visual platforms on the world. We find overall engagement remains stable and consumption diversity increases. And for about a section of the users who engage with previously underrepresented content, engagement goes up by 11%. Thank you so much. I'll just pause here for questions. I'll give you 2 minutes for questions. Thank you. Yeah, there's a question already.
Yeah, just out of curiosity, because you see the historical data and kind of can inform my preference.
Yes.
Can you use that to make decisions, or
Yes.
will your lawyers shout at you?
No. So I think there are 2 parts to that. Let's just say first, I think your lawyer argument is valid. But even if we could, the question is whether we should, right? In as much as we think that some sort of content should be kind of broadcast to everyone, because let's just say these are forming beauty perceptions in the world, it's not obvious that every type of content should be personalized. It's maybe a little difficult to see it in this case, but let's just, for the sake of argument, take this to be news. Would you say that if I know that some person prefers left-leaning news versus right-leaning news, should I only show them that? So I think, this is a stretch of an example, but just to kind of drive the point home, that it's not always obvious that you want to personalize content just because you can.
See, so the platform stance is that they don't want to make use of the signal to do things, despite the fact that they might
Right.
legally okay with it.
Yes, I think our stance is that I should say that this is all, let's blame the authors and not the platform. So our sense is that it may not be obvious. I think that's a step that we're exploring, but I think to me it's not obvious that may be in the best interest of the users or the platform. Yeah.
One
Yes.
more question, but let's set up the next presentation.
Oh, sorry about that. Yeah.
No worries.
Yes.
I've tried to learn the race of the models and try to diversify along those lines instead of maybe using skin tone as a proxy for that.
Yeah. So let's just spend some slight technicality. It's just way easier to measure skin tone than it is to do race. Because skin tone can be kind of inferred in this scalable, unsupervised way, whereas for race, you need label data. So it's just a way more scalable approach to do it using skin tone.
Was there any approach to like seeing if the skin tone results like mapped well to race or?
We haven't done race. I think
Okay.
generally we just kind of want to stay away from race from a kind of maybe legal reason, but also technically it's just been much faster to do that. And people taking time away from the other presenter, but happy to chat.